Gravitational potential energy is the energy stored in an object that is prevented from falling to the ground. Pretty much everything in the universe has the potential to pull other objects towards them, and so everything has gravitational potential energy. From our previous discussions on energy, we know that it is equal to force multiplied by displacement in the direction of the force. The force of gravity only acts in one direction, straight downwards. This means that you can only gain or lose gravitational potential energy by moving vertically. This means we need not consider the proportion of force in line with gravity. There are no cosines involved. The force due to gravity is weight. From Newton's second law, we know that a force is equal to the mass of the object multiplied by the acceleration the object is experiencing. Assuming that the mass of our object stays the same throughout its motion up or down, we can stipulate that the force due to gravity is mass times the acceleration caused by gravity near the Earth's surface. This is fairly constant around the world and is given a value of 9.81 meters per second squared and a symbol, lowercase g. In fact, the acceleration due to gravity on any planet or planetoid or massive body is given the symbol g, and it does vary from place to place. On the Moon, the value of g is roughly 1/6 of what it is on the Earth. Distances involved in gravity are always vertical. As gravity does not act in any other plane, it is pointless to discuss the horizontal aspect of gravity. It has none. Vertical displacements have a common name which is easier to use: height. The change in gravitational potential energy is equal to the mass of the object experiencing gravity multiplied by the acceleration due to gravity on the planet multiplied by the change in height the object travels through. Because of the conservation of energy, the energy lost or gained in a system will be equal to the final gravitational potential energy minus the initial gravitational potential energy of a system. This means that if we know the change in gravitational potential energy and the final gravitational potential energy, we can work out the initial gravitational potential energy. We can also work in reverse to know the final gravitational potential energy given the change and the initial energies. Finally, if we are given the initial gravitational potential energy and the final gravitational potential energy, we can work out the change in gravitational potential energy. You should remember that it is very important to maintain the correct direction in these equations. An energy gain is usually when the amount of gravitational potential energy goes up. This means that motion upwards is positive motion, as this leads to an increase in gravitational potential energy. Make sure that your directions are consistent in any discussions you may have.